Am I live? That's the question. Okay. Hopefully, let's wait for a few seconds. That's done. Yes, I am live. Cool. Sorry for joining late on the stream, but okay. Today I want to explore this Fluent protocol, Fluent Fluent chain. Let's say that's the correct terminology. Hopefully, I have been following that protocol for a while, and it seems like a good good protocol that at least I am interested in. So I decided we I should create some content around it. I want to create actually the guides, but the issue is I'm not very accustomed to Rust. The You don't need Rust, but we'll we'll learn about this, like where uh, it actually gives you multiple options to work with. So it has EVM, it has WASM support, it will have SVM support. So that's why I want to check it out, where we can actually create different things. Let's open Excalibur. Okay, let's convert this black dark. Cool. So now we have Fluent, Fluent, Fluent. Cool. ENT, Fluent. Okay. So if we start with this, what is Fluent? Fluent is Fluent is first blended execution network, an Ethereum L2 and framework that blends WASM, EVM, and soon SVM based smart contract into unified execution environment. Smart contracts from different VM targets can directly call each other on Fluent. Fluent is in public DevNet and currently supports apps composed from Solidity, Viper, and Rest. Okay, so this this is the basic value proposition for Fluent, where y- you, if you are a developer from Solana ecosystem, if you are in EVM, or even if you are just WASM based, you want to write WASM based contracts. I don't know WASM. It's like, does it supports COSM WASM, or if you if you don't know what COSM WASM is, COSM WASM, it's Cosmos WASM, Cosmos WebAssembly kind of thing, where you can write Rust contracts on Cosmos, but I'm not sure if that's the same environment that they're saying here. But general idea is, it doesn't matter what ecosystem you come from, you can develop here on Fluent. So this is like the Fluent box execution environment. It has multiple VMs supported in it. It's not it's not like a box, but just assume this is the actual execution environment. So Fluent VM, we can say Fluent VM. Then there is EVM, there is WASM, 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 and there is SVM. So if you are a developer from EVM, you can't um, no EVM like no EVM chain supports any of these smart contracts. That's why if you go on base, like you have to write Solidity, and probably you have to go much deeper into it. So here instead, what you can do is you will have this particular what you can say. You can write a REST-based smart contract on SVM, uh, like you write in SVM, not on SVM, but whatever you write on Solana, you can deploy, and then that contract can talk with this contract directly without any. They can talk with each other, and we'll go over this. Here they show example of how blended app works, and I guess SVM is not supported, so they are doing the Va- WASM smart contract. So this is Rust smart contract, but not like SVM Rust. This is their own thing. So Fluent SDK. So we'll come to this. Yeah, right now we can ignore the part where what this particular smart contract does, and we can do deep dive into Fluent base, but I'm not very good with Rust, so I can give you s- simple overview what this particular contract is doing, but I'm not gonna write anything in Rust. I'm just gonna deploy this as it is, and then write a what do you can say write a Solidity smart contract that interacts with this. So I can do some modification. I'm not that uh, dumb where like I don't understand what's happening here, but I'm not very well versed where I can write and explain everything to you in very detailed manner and like an expert. So I'm just beginner with Rust. Keep that in mind. Okay, cool. Next, um, yeah, you saw this. Right now, we can just ignore this. Can we have some kind of how do we do that? So yeah, this is not working for now. You can say. So let's keep this here, and we can say support support coming soon. Now we we understand like what this part is, how they do it, but without Fluent, like how would you go about um, creating something like this? This is not impossible, but this is not also in the real world, like right now this is not feasible. Not feasible in the sense uh, it will take a lot of time. You have to write contracts in a different manner where you have to depend on bridges or intent based services, and you have to do like a lot of things, extra things, which you don't have to do here. That's the main advantage of Fluent. Right now, if you want to do something, uh, here we have what? Here we have this EVM. Like, let's say base EVM, and you have Solana SVM. Oh, SVM. Then there is a contract here and a contract here. Can we say contract A and put it under here, duplicate it and say contract B. So for, this is real world. Um, this is what we have to do right now with Fluent VM, and then we can say without Fluent VM. Let's make it bigger, give it a different color, delete this. Okay, so now what happens? You see, where here both of the developers are in the same on the same blockchain and same ecosystem, where they can use each other's contracts very simply. Here it won't happen that simply. Now we have contract A, contract B. We understood that. There will be other contracts. So this will be, let's say, bridge. Let me change the color and zoom in. This will be bridge contract, and again be a bridge contract. So contract A wants to talk to contract B. They are in different environments, and no one will actually do this. They can do for same stack. So if you are EVM, like there is a chance you want you want contracts from chain A and contracts from chain B to talk with each other, but there won't be any scenario like I don't know any apps that are doing like EVM to SVM calls and then talking with each other. One part is that's not feasible, maybe. That's just too time consuming uh, because of bridges and all the round trip of data that needs to happen and confirmations, everything that comes along with it. That's why that's not possible, or maybe it just EVM apps don't want to work with SVM apps. I don't know what exactly that what the reason is, but that's the assumption. So we have our first call. If condition contract A wants to get data from contract B to do some calculation, and if calculations are correct, then do something on contract B. So that this is our statement. Like it wants to get some data, and if that data is correct, then only we should perform an action. So for that, how the flow will be basically flow in this scenario will be contract A calls this bridge contract, which will pass some data on to different chain. Correct? Then this contract will pass that data or that request. So let's say sends request for data. Go down. Okay. Pass on the request. That's that is what is happening here. It returns the data. Then again it has to return data back, and again return data to this A. Check if data is correct. Now this will happen at this point. Let's say send request for data. This is the first step. This is the second step. And then here it will be third. Let's make this bigger. Now, okay. Correct data. Then send action request. So the request that will perform some action. Let's make it smaller. I know you won't be able to see this, but just remember that. Or we can just say send action request. So this action request is basically, if data is correct, it will send the action request to go here and go here. Now here. Do perform the action. Cool. We perform the action. Now send the confirmation of that action back. Here. Log action performed. Cool. So this action performed is basically we are getting that data back when an action is performed. You can see all the calls here, and there is a caveat. Action request. For all these things, if they are in same VM, like a EVM, all these things will happen. There will be these many calls, just these intermediaries won't be here. But because of they are in different VMs, what issue happens is this contract sends a request to bridge contract, which is instantaneous. Then this bridge contract sends a data from EVM to SVM, and in this particular part, let's say yes. So this part, this is some relayer or what again solver, whatever the name is. These things are acting here, which are decentralized enough and there are good enough trust assumptions but sending data from one chain to another, it takes a lot of time. If you think of a transaction, it's not straightforward where you do cross contract call in the same VM and in single transaction everything happens. Here we have this one transaction first, which goes to this new like VM. When we send request here, this relayer creates a new transaction. So transaction 1 from contract A to bridge contract on EVM. Second will be from resolver to Solana. We bridge contract on Solana VM, SVM, and this call will happen. So this is like a single transaction. This is pretty quick. No, not this. This whole loop is single transaction. Here we have one transaction, and this loop will be another transaction. So 1, 2, 3, now 4 and 5. So there are 5 distinct transactions which are happening. If EVM contracts wants to talk with SVM contract and perform some action, which is pretty time consuming, and you have to do a lot of things here where you have to create some oh sorry, you have to create some, we don't need bridge, but cross chain like arbitrum to optimism, we okay Aditya, we don't need bridge contract for EVM to EVM transactions, but cross chain like arbitrum to optimism. Yeah, that's the idea. Like in the Fluent, what their idea is, they have blended VM, so multiple VMs in single under single virtual machine. They support for EVM, WASM, SVM, everything, and that's the beauty of Fluent basically. Here, I'm just showing like if EVM contracts wants to talk with SVM contract, what will happen in the same VM. All these transactions are not needed. Cross chain, we do need this, um, even if they are like both are same VMs. So I'm I think I answered like right, Aditya. Hopefully I answered the question, but that's the idea where you don't have to do all these things. Everything will be under a single VM, and any developer can come here and deploy their contracts. Uh, EVM contract can talk with SVM contract and WASM contract. So that's their like MO basically. Um, value proposition where you can come from any ecosystem and just deploy whatever you have. You don't have to modify anything or do some changes. That was their idea. Okay, now we understood this. Like we have some idea what will happen here, what will happen with Fluent VM, and what will happen without Fluent VM, or what is happening right now. That was the idea, right? We saw the Fluent. Next, connect to DevNet. So this is just um, just like their entry point uh, node, like RPC endpoints and all. So current features and limitations. Okay, this is much important for us. In this version, the offering includes a basic REST implementation. Okay, I know what this is. Basically, paradigms implementation of ETH node, then where the execution environment is substituted with Fluent VM, comma RWASM. Okay, RWASM is just, I think it's Rust WASM. Okay, I need to see this. Rollup and ZK functionalities are not available at this stage. Cool. This is a DevNet, so we I don't really mind. It's essential to note that significant changes might occur in VM structure, host SDK, and execution layer in subsequent releases. Understood. Just fast, fast track, fast track, or like in alpha version, so everything can break. Everything and every feature will break. That's what they're warning about. Okay, build with Fluent base. This is the main problem because this is in Rust, but we don't really need this. If you want to create a blended app, which we have here, if you want to create a blended app, then you need to understand Rust or something like that. Otherwise, it's good to go. Okay, deploy modules, create bin creator, create with binary application that is used for translating WASM apps to Fluent RWASM VM is required only for creating system precompile contracts, while direct translation from WASM to RWASM is needed. Okay, creates contains all Fluent based modules, codec, encoding, decoding, cool, contract, create with all system all systems precompiled contract that brings support of different execution environment compatibilities, including EVM, SVM, WASM, and all corresponding systems like Blake 2, SHA-256. Understood? Core outdated. Okay, we can ignore this. This crate is also available. RVM crate. That's pretty interesting. Maybe with this you can directly access all the functions from Rust. All the functions that are public, or yeah, that hopefully that are public. We have this crate. We don't have this crate for some reason. Why? This is orphan, not finished. There isn't any RVM crate. Core types and Genesis. We saw a bunch of them, right? Genesis, Genesis, Poseidon. Okay, cool. Maybe I should note this down so I can ask the team. Supported languages: Rust, Solidity, Viper. Cool. Example code: Fluent Base can be used to develop different types of applications. In most cases, the same interface will same interface is utilized. Here is one example application that can be developed using Fluent Base. Greetings, deploy, any custom logic. Okay, this is like a constructor, let's say. So whenever it is deployed, this function will execute. That's the idea. And then main. Okay, main function. LTK write hello. This just writes hello. Fluent base operation. Fluent base operates using Fluent RVM, reduced WebAssembly. Okay, it's not Rust WebAssembly. RVM is reduced WebAssembly. This VM employs 100% compatible Wasm binary representation optimized for ZK operations. The instruction set is reduced and sections are enabled inside the binary to simplify the proving process. Okay, I don't have any idea how these ZK operations might work. Maybe if there is a chance, I can in the Fluent builders Telegram, I can ask them. Um, is there any examples how this is useful for developers, or what developers might use this? Because ZK, no, I don't know. Other than ZK rollups, I haven't seen anyone use ZK operations in the contract. Maybe Tornado Cache, but I don't know if they were using ZK. Understood. Let's go next. Limitations and future enhancements. As of now, Fluent Base does not support floating point operations. However, this feature is on the roadmap for future enhancements. Okay, whatever we are gonna do doesn't require any floating point operations. Next, developer quick starter. Get started with Fluent. Get started building on Fluent. Fluent allows developers to write smart contracts in Rust, Solidity, or Viper. Each language has its unique advantages and syntax, enabling developers to choose the best fit for their projects. Understood? This guide will walk you through creating a Hello World contract in each of those three languages and deploying it on Fluent. Get started. To simplify the setup, your project can be bootstrapped using Fluent's Scaffold CLI tool. This tool automates the creation of project structure and necessary directories for smart contract development. Install Scaffold CLI tool. To install Fluent Scaffold CLI tool, simply run the following command. Cool, let me open the VS Code. Okay, it's starting. What should we do? See, let's go back to streams and create a new project. Fluent quick starter. Oh no, make directly. mkdir and and now we can switch open folders. Right now it doesn't really matter what we are doing here. It's just empty folder. Let's run the command we saw, which is install gblend cargo. I already have Rust installed, so probably if not, then go to like rust.org. That's the website of, yeah, and install that. cargo. Okay, working. Let's wait, or we can go back to browser and just see. To create project, run following command. Okay, gblend in it. This will prompt you to choose from available setup options, which are Solidity, Viper, Rust, uh, and we can do this. We'll do hard hat JavaScript. Select options that align with your preferred programming language for smart contract development, and CLI tool will set up the project structure accordingly. Let's go to Solidity. We have to run one command, gblend in it. We should keep. Oh, it it is repeating that here. Let's go back to VS Code. I'm still installing this. Not yeah, installing this. So let's wait for a while till it's installed. Then we can run the init command and see what's happening. Okay, I know one is Aditya. Like, who is the other one? Rest two are me and my brother. So, uh, where is the third, fourth? I don't know who that person is. But cool. Aditya, thanks for joining in, man. Gblend init. Oh, we should close this. Gblend init. Blend. There is also blended app. We can try this one first. Let's close this. Okay, simple, straightforward greetings, returns hello world. Nothing complex here. Viper, it's also the same thing. Deploy solidity, nothing new here. It just const ethers, then the script creates signer, gets the network, deploys this. This is just, I think, no, this is just console logs for what chain it is, and deployer address and balance basically. This is where we deploy and it returns the contract. And main function. Back to docs. Yeah, docs. Here it's a project structure. We already saw that. Then next will be getting started. Okay. Before we interact with our Hello World smart contract, run the below command to install all the dependencies in the package.json file. Understood. Package npm install. I don't know if this will happen or not. Most of the time npm throws an error. So most of the time it is failing for some reason or another. That's why I just use this yarn. Okay, worked. Pack package.json. It installed just basic things like ethers, hard hat, network helpers. What we do most of the time. Now here it creates. It has the test account. This is not ours, so we don't really mind. What is the next step? Back back to this. Back to docs. We already went through hard hat configs, what it is doing. Within networks, you can Fluent object devnet 1 configuration. This specifies the URL to connect to Fluent devnet along with chain ID and the accounts available for transactions. Use Fluent faucet to request test tokens. Okay, compiling the contract, npm run compile, deploying the script, just the same thing. Okay, let me create this, create a new account. uh, I'm just I know we are using hard hat, but I'm gonna use forge. Create new account with foundry CLI. I'm just trying to find the command. Oh, not forge, cast wallet new, cast wallet new. Just pasted. Oh no, cast wallet new, generate it, and let me copy the uh, address. New file, readme.md. Okay, cool. Now you can see here, this was the new basic address, and I haven't used any of the other things to hide the private key, because this is just test wallet, and probably it's a good idea to use wall not use wallet that I create on the stream, just as a precaution. Back to browser, and we want to get the tokens for, from it. Block Explorer. Why? Block Explorer. Is there a, yeah, there is dark theme. Thank, thank you. DevNet. We got some. Yeah, we got test teeth. We can go back to our project. Let's run npm run compile. It's doing something. We should wait. Okay, it compiled both of them, which we don't need. We don't need to do that. Now we need to deploy it, which is the command is npx hard at run scripts deploy dash solidts, and then the network name of the network, npx hard hat run script slash deploy dash deploy solidity dot js dash dash network fluent devnet 1. Okay, hopefully we have deployed the contract. We can copy the contract address and go to block explorer pretty quick. We have deployed it. Okay, don't know. I haven't done this through this file, this method. I always done it with the CLI or with the code. So single file compiler. What compiler did we use? It was 1819 Paris, and then the code. We can paste that code. Invalid metadata chain. What is this? I don't know. Uh, if your code utilizes a library or inherits dependency, we recommend using other tools. Can we Solidity hard hat? Okay, via plugin. We can add. I don't want to do this today. We okay. We have done this. We have come till this point. Rest we don't want to do. I don't want to do. Viper is pretty straightforward, same thing because we are still using hard hat. So it'll be the same flow, same commands. You can npm run compile, and then the script name will change, but everything remains same. Building building the blended app. Okay, this is pretty interesting because we saw in the scaffold in the CLI tool there was option to create a blended app or a solidity hard hat app basically, and we chose to do the hard hat for today. Tomorrow we can go through blended app and see like for how they are structuring it and what is there. So that's the plan for tomorrow, and we still have 10 minutes, but it's not enough to cover any interesting topics. So that's it for the today stream. See you guys tomorrow. Hopefully you like this and maybe explore Fluent. That's the main idea. It's not more about the stream, it's more about the project and how interesting it is. We we have few more interesting projects to go through after Fluent, but this was pretty interesting idea and new idea, so that's why I wanted to cover this in on stream. Okay, cool. I hope you like the stream. See you guys tomorrow same time. You know what the topic will be. Cool. Have a nice day. Bye.